Hey gang, when we deal in isolation in a virtualized layer 2 infrastructure, VLANs, we've got two flavors to work with. We've got ISL and you've got 802.1q. Guess which one of those we're going to use? Not ISL, right? That's old, it's Cisco proprietary. We use the standard, right? Most of our devices now even specifically only allow us to use 802.1q to handle our trunk links. So remember, the trunk links are not what we have going to our clients, but instead what we have going between our switches. Each of these is a trunk link. Other places where you might see a trunk link would be to a virtualization service like Hyper-V or VMware, to a router, or to a layer 3 switch. These are all layer 2 switches in this diagram. Layer 3 switch would have that, or a WLC, a wireless LAN controller. Now, remember, with 802.1q tagging, you essentially have frames, right? Let's say this device in layer 2, in VLAN 2, is trying to communicate with this device, which is also in VLAN 2. I need all these switches to function like one big switch as far as VLAN 2 is concerned. How does that happen? Well, we're going to insert the VLAN ID number once we've received this frame and we realize we need to forward it over an 802.1q trunk link. So I need to tell the next switch, hey, I've got this frame to forward, and by the way, it belongs to VLAN 2. And so it will literally inject that, it'll insert it, it will tag the frame with that extra number in the layer 2 portion of the frame. That switch then realizes it needs to forward it on as well, so it keeps that VLAN ID in the frame, forwarding it on to the next switch. This next switch does what all switches do, it looks at its MAC address table. But here's the interesting thing. With VLANs, you have a MAC address table per VLAN. So I receive the frame as a switch, I see its VLAN ID too, so therefore I check, can I forward this frame by looking at the VLAN 2 MAC address table? That's the only one I look at. And then as a switch, I'll find that destination MAC address in the MAC address table. I will remove that extra portion of the frame. It goes back to its original frame configuration without the extra VLAN ID information injected in it, tagged in it. So the native frame essentially now reappears and is forwarded to the server. So the server receives what looks like a regular frame as if there was no VLAN process going on. Remember, the client and the server know nothing about VLANs. Their job is simply to send frames out to the interface, right? To use the interface to work with the switches and devices that are out there. So trunk ports are all a part of the infrastructure. They're all associated with the interior of working through our network, not the exterior. Now, with that said, when I reach the edge device of a router or a routing service, so that could be a router, it could be a layer 3 switch. We also could include in this a wireless LAN controller. In these sorts of configurations, we will also see trunk ports. For example, with routers and layer 3 switches, we will have virtual interfaces per VLAN. So I'll have a VLAN 1 virtual interface, a VLAN 2 virtual interface, and a VLAN 3 virtual interface, so that with one physical link, I can receive something that, let's say, came from VLAN 1, but I can send it out the VLAN 2 virtual interface to be able to get to the destination. So inter-VLAN routing happens through virtualized interfaces. That's what makes it great. I don't have to purchase a physical interface for every VLAN. I can use logical ones. And of course, layer 3 switches can do that at switching speed.